Okay, let's start with thermodynamics. It basically deals with energy change involved in the process. It deals with energy change involved in the process. Though there are three types of system. First one is open, second one is closed, and third one is isolated. Open means in which exchange of mass and energy is permitted, while closed means in which only energy exchange is possible. And in isolated, neither mass nor energy exchange is possible. Adiabatic, no heat transfer is there. Diathermal means heat can flow. So both are actually inverse of each other. Now there are two types of basic properties: extensive and intensive. So extensive means mass. Extensive properties depends upon mass, like volume, internal energy, enthalpy, entropy, etc. Intensive properties means those which doesn't depend on mass. It means intensive means independent of mass. So these are pressure, temperature, etc. Now there is a point like ratio of two extensive is intensive, like mass upon volume is equal to density. So process is those process is a phase in which volume, pressure or temperature changes. Isothermal means those process in which delta T is equal to 0, means temperature change is not there, but converse is not true, means delta T is equal to 0. It doesn't guarantee that the process is isothermal. Now another one is isobaric. Isobaric means delta P is equal to 0. Isochoric means delta V is equal to 0. Quasi-static pressure, it's very slow process. Types of function, there are basically two types of function: state function, path function. State function means are those functions that doesn't depend upon path, and path function are those that depend upon path, on which path you are going. So state functions are q and w. Path function are rest of them. Q and w means heat and work are state function, and rest are path function. Heat means energy which is transferred due to temperature distance. Work is that form of energy which is transferred from any other means other than temperature difference. So heat is very disordered form, and work is actually ordered form of energy. So sign convention: heat means heat due to temperature difference. Work is transferred due to any other means other than temperature. Sign convention: heat loss by the system negative, work done by system expansion. See, heat loss by if body is losing heat, it is negative. If body is doing work done by system is negative, like expansion is negative. So W is equal to minus P dV. First law of thermodynamics is equal to U is equal to Q plus W. Irreversible process means definite number of steps and constant external pressure. In reversible, their pressure is very varying because number of steps are very high, infinite. So pressure will not hold till then. So in irreversible, definite number of stops, and it is done against constant external pressure. Now what done calculation of isothermal process. So first in case of compression, see, we are calculating work done for isothermal process. The first one is compression. So irreversible isothermal process, W irreversible is equal to P delta V, because P is constant, so it can be taken out. Irreversible isothermal means pressure is varying, so we are using nRT ln V2 divided by V1. Now again, in case of isothermal process, W irreversible will be equal to W reversible, and W irreversible will be greater than W reversible. In case of expansion, irreversible work is equal to minus P exterior delta V. Reversible is equal to minus P dV. Irreversible means P exterior delta V. Reversible means P dV. W. Okay. So irreversible work. Now in this case, in case of expansion, reversible work is more than irreversible. It means what? Expansion favors reversible, and compression favors irreversible. Okay. So work done is like that. Isothermal in every case, ideal gas should be greater than van der Waals gas. For reversible adiabatic process, PV gamma is equal to constant. Now W reversible ideal is equal to P2 V2 minus P1 V1 divided by gamma minus 1. P irreversible ideal minus P exterior V2 minus V1 minus P exterior V2 minus V1. Now again, there is free expansion. Now delta E is equal to NCP delta T. Pre-expansion. Pre-expansion means what? There is no external pressure. It means that vacuum is there. So work done is equal to zero. Now in pre-expansion there are two basic cases: isothermal and adiabatic. In isothermal again there are two cases: ideal and real case. In ideal case P is equal to zero, so no work is done. Again in adiabatic also P is equal to zero, so no work is done. In real gas for isothermal it absorbs heat, and in adiabatic it releases heat, so temperature decreases. See, isothermal absorbs heat, so temperature increase. Adiabatic, so temperature decrease. Specific heat, it's for 1 gram, it's heat required for raising the temperature of 1 gram of solid by 1 degree Celsius. Heat capacity, m gram solids by 1 degree Celsius. C is equal to ms. Q is equal to C delta T. Now ms is equal to delta T. So molar heat capacity at constant value is equal to Cp. At constant value it becomes Cp. Cp minus Cv is equal to R. Cp upon Cv is equal to gamma. Gamma is always greater than 1. So Cp is greater than Cv. So again here, now there is one Gibbs free phase rule that determines like P plus F is equal to C plus 2. Means number of phase plus degree of freedom is equal to C plus 2, component of plus 2. Degree of freedom, number of ways in which kinetic energy is distributed, called degree of freedom. Total degree of freedom is equal to 3, and where n is equal to atomicity. Monoatomic means gamma is equal to 1.6 and degree of freedom is equal to 3. Diatomic means gamma is equal to 1.4, F is equal to 6. Triatomic means gamma is equal to 1.3, F is equal to 9. Carnot cycle is actually combination of two different cycles, isothermal and adiabatic. So 1, 2 and 3 for isothermal, 2, 3 and 4, 1 is adiabatic. N Carnot is equal to W net upon Q2. It means T2 minus T1 is equal divided by T1. Second law of thermodynamics basically comprises of two laws: Clausius statement and Kelvin-Planck statement. Clausius statement says it is impossible to pass heat from cold to hot without some other change. Means you can't transfer heat from cold body to hot body without any external means. Kelvin-Planck means impossible to construct devices operating on cyclic process in which there is no other effective substrates except absorption heat from hot. Means there is no any system device which uses cyclic process and it takes energy from reservoir and complete into work completely. Means impossible to model 100% thermal efficient device. That's the basic theory of Kelvin-Planck statement. Now there are entropy. Entropy means what? Randomness or disorder. Gas randomness is more than liquid than solid. Q is equal to Q reversible divided by dt. Reversible. Entropy is equal to Q reversible upon dt. S is equal to entropy. ds is equal to dq reversible by dt. J per Kelvin is basic unit. It is actually a state unit. Enthalpy. Enthalpy means what? Heat content of body is called enthalpy. H is equal to U plus PV. H is equal to U plus PP. It's like constant volume. Delta H is equal to delta V because delta PV is equal to 0. Gaseous state. Delta H is equal to delta U plus delta Ng RT. Means Ng represents only gas mole, not total mole. Gibbs free energy used to calculate maximum reversible work at constant pressure and temperature. Used to calculate maximum reversible work for constant pressure and temperature. Delta G is equal to delta H minus T delta S. Delta G is equal to delta H minus T delta S. Delta G is negative means spontaneous. Delta G is equal to 0 equilibrium. Delta G positive means non-spontaneous. Endothermic reaction. Delta is equal to positive. Exothermic. Delta H negative. So for endothermic at low temperature, delta G is equal to positive, so it's non-spontaneous. At low temperature for exothermic reaction, delta G is equal to negative, so spontaneous. That's the basic int. So here is different, like Carnot cycle helps to determine maximum efficiency of heat engine developed by Sadi Carnot. It determines maximum efficiency of heat engine. 1 minus Tc minus Th. So walls, its assumption of walls and are perfectly non-conducting, but bottom is perfectly conducting. Source and sink are of infinite heat capacity. It will do this.